Hello, everyone, and welcome to Clara's November webinar. This time, we're having a fireside chat with Benedict Reuschling about FreeBSD infrastructure war stories. Thank you for
Oh,
joining us,
yes.
Benedict.
Well, thank you for having me. It's nice to have this kind of talk next to the fireplace or the virtual one. And yeah, looking forward to this. So originally, this should have been a conference talk, but it never got to that. So I thought, why waste that? And because it's still relevant and useful, I think. So that's why we're doing it in this kind of format with Clara.
Yeah,
And yeah,
so I guess you're going to start us off with basically 3 different stories.
yeah.
So
Directly from the trenches. So all of these happened a couple of years ago, so they're not too fresh, but still in its core relevant enough to be serving as some kind of cautionary tale. And everyone will probably have a good laugh and have a couple of pictures there to see also what the systems were telling us. Okay, so the first one is log rotation on the root partition. And that is basically bad practices, which you should never do. But well, when you were starting out, so like I did at the university as a sysadmin, you start running your first servers and people like those and they become popular. And yeah, before you know it, you have a lot of users. In this case, it's a Postgres server, and that is used for the database classes, about 200 users. So we have 4 groups, each about, by that time, this is the 4th or 5th semester, depending on how far students have advanced already. And that's 50 times 4 users, and that's 200 in total who are in one semester doing this class. Okay, so I installed this thing and made it available, and you can see in the second bullet point, it already goes to hell. I didn't use a jail, and all was installed on the base system because I thought, hey, there's enough disk space available. Okay, and that worked fine for many, many months, and all went good, and even multiple semesters had no problems until one fateful day when it was reported to me. I wasn't working on the system myself, but heard it from another person that the system is very slow today. What is going on? And also, oh, the students can't log in anymore. And that's a problem because we only have like 5 or 6 labs in total during the semester. And if one lab is not happening because computers are on strike or not working in all kinds of manners, then it's a problem.
yeah,
Okay, so
it messes up the schedule for the whole semester, basically.
yeah, that's my production
this,
environment, right?
Yeah, it's important that this doesn't get missed.
Yeah. And so you might laugh about this because it's not a 24/7 high availability machine that is running some kind of web server or some crucial application that causes a lot of trouble when not working. But at least these 200 users need that server, and the professors too, to show these examples in databases. And so that didn't happen that day. Okay, so then they reported that the students can't log in anymore. That's a problem because, well, from the console, they can do at least PSQL or some extra applications that they had installed for them. But no one could anymore. Neither could I, trying to fix the problem. So I had to go to the console of the server, like very basic, back to the roots.
When you can't even access the system to try to fix it, you're in more trouble than you would think.
Yeah, because remember, if you are on a UFS system, there's typically a little reservation for the root user also, so that that user can still log in if the disk is starting to fill up. But apparently that was also not the case. So you kind of sketch together while a lot of people are breathing down your neck. When is the server available again? Can you tell us already something? No, I can't. I'm still analyzing, and go off. I need to think. Okay. So what I found out that SSH could not start the sessions because no space left on device. So you might think, oh, wow, how much space would SSH logins need? It's a tiny, tiny bit of kilobytes that it needs to record this user just logged in, but couldn't even do that. So no space left on device.
Yeah, if there's 0 space less, it doesn't matter how much space you want, there is none.
Yeah. And some of these systems could even over provision, like UFS could do a little bit over 100%, but that was already, not there
If
anymore.
there's a couple percent reserved for root, but it's being used by root, then you're past 100% and you're out of space.
Mm. And so then you try to run a couple commands, and it's fairly interesting to see what commands do or not do when there's a low disk space situation. Especially they take a long time because they also need to allocate memory or use a little bit of disk space for temporary files. If they can't be stored, well, then it's a slow process. So, but eventually I figured out, okay, with a couple of DUs and figuring out the typical partitions. Is it in home? No. Is it in USR? No. Is it in var? Oh, yes, there's 37 gigabytes of statement logs there. So if you know a little bit about Postgres, Postgres has a separate directory where it stores its database cluster. It's not a cluster with multiple machines typically, but that's the naming convention they use. And there, in that directory, Postgres stores all its files as well as the log files. If you don't put a separate subdirectory there, it all stands there in this directory. And there I found 37 gigabytes of statement logs. So statement logs are all the logs that deal with the SQL that people put in, like any insert, update, delete, or create table statements. That was typically there to help students debug certain problems or figuring out, hey, why did that statement not run on the server? And that's why the statement log was active in that case. But no log rotation was configured for this kind of log, nor a statement timeout was configured. That becomes interesting in the next bullet point, because
but even before that, looking at it, log rotation is helpful, but if you're out of space, you can't even rotate the log, because normally what you do is you'd rename it, which might actually take additional space. But even then, if you're going to compress the log to try to save space, you need some free space to write the new compressed version into before you delete the old version. So all of these operations need some space in order to be able to happen. And when you have run the system completely out of space, you can be in this odd situation of, I don't have enough space in order to do anything to free up some space.
Oh yeah, that's the culprit. And yeah, you learn these things because they happen, and then you're wiser. But in that situation, you're kind of sweating already, and you kind of think, okay, the day is over before it started. But doesn't help. You need to fix this. You're the sysadmin. And so what happened, looking at that 37 gigabyte statement log with tail, because I'm not starting on the on the first kind of lines on this 37 monster, I found that there was a loop running from a student program or a stored procedure. So these are basically little programs that you could store in the database server itself, and you could call them to execute certain actions like increase the price by 19%, value-added tax, or other kinds of assignments. So that was part of the assignment, write such a stored procedure. What the student managed to do was to create an endless loop in that stored procedure, so this never ended. But in that procedure, it allocated memory or was doing inserts or writes on the disk eventually. And so you have a process that's running and running and running with no end in sight, and that is allocating disk space slowly but steadily. And I don't recall how long ago this procedure had started, but apparently it was long enough to fill the 37 gigabyte statement log file. And Postgres was happy to record all these actions in that endless loop and recorded it on disk for everyone to see for all eternity. And of course, the disk was at one point saying, no, I don't have any more to give you. I cannot store more than you request. And here we are. So everyone is, of course, now thinking, yes, this could never happen to me. And how stupid could you be setting this up? But remember, we all started somewhere. And the learnings from that is never having this situation again. So next time you think about how could I prevent this to make this not appear anymore and not go through those painful experiences anymore. So what do? You start looking at quotas to limit the disk space by users or applications. So ZFS has good quota management for that, and my Postgres server all run on ZFS these days. So this server was pretty much set up anew and with all the learnings in place now. So I had used a ref quota for that was big enough. And I also created a quota on the root pool for the sysadmin user to just in
a
case.
Reservation rather than a quota, right?
Or reservation even, yeah, even better. Or combine the two, reservation and quota.
Yeah, so with a reservation, you're basically saying, all the free space in this pool is shared between all the file systems, but this one file system, it gets the last 10 gigabytes or whatever of space. It's that space is dedicated to only this use case, so that you'll always be able to log in.
Oh yeah. And of course, now you think, oh well, if this would still happen, why would it bring down the host system, right? So if you put all of these applications that are potentially misbehaving in a little jail, then they could allocate that jail's disk space as much as they like, but this host system hosting that jail would not be affected. You could still access that machine and try to stop the jail or look around or at least log in via SSH. That's something I learned from there. Isolate applications because they might misbehave and they don't affect other applications, because that server could easily run other applications like a web server or other kind of applications all in this machine. But if they all run in the base root host, then of course, if one application misbehaves for whatever reason, it brings down the other ones. But if it's a jail and nicely isolated, then one misbehaving jail affects only its application and not the other ones.
I guess to that point, somebody, one of the attendees has asked a question here. Did you consider giving each student their own separate jailed instance of Postgres? Or did they need to all be sharing the same instance?
Yeah, that's a good remark. I was thinking about that. So you could easily create 200 data sets and create a separate Postgres server for that. But the learning experience there for the students was, because everyone could run their own Postgres server on their laptop, right? That doesn't need too much disk space. And we did that in the pandemic when they couldn't get into the university. But the point here is that students should also learn that they are not alone on their system. They work with other users and that there are permissions in place and that you can't access all the other databases, and there are schemas and all kinds of application level permissions that the database has, like grant and revoke permissions. So that was part of our learnings, that we also want to teach this. Because if you're like on your own computer, you typically have one user or two, root and yourself. You typically don't share that with the rest of your family. If it's a server, then it's kind of a different story, right? There's multiple users there and they need to be properly isolated. And we wanted to show the students that this is also possible on the database level.
Yeah, although maybe in a middle ground there would be breaking it into each of those 4 different groups you talked about, of 50 students each having their own, so that if someone does cause a problem on the database server, you're only impacting the rest of their class, not all the classes at once. Although, since the classes probably aren't running concurrently, in that case, you might actually be better off breaking each group of 50 up across the 4 instances, so that if during a particular class somebody breaks something, it only takes out a quarter of that class. So each of the 4 instances is supporting 1/4 of each of the 4 groups, so that you get a broader distribution of more separate fault domains. Because if somebody does break something, you can go and fix that before another class needs that machine. But when it happens during a class, if you can avoid taking out the entire class, at least you can have some middle ground.
Yeah, that's good. That's why I like these kind of webinars with sysadmins. They have all kinds of interesting, similar problem solving skills. And of course, that's a good suggestion, right? If the Monday class is affected, then the Friday class doesn't hear about it until it's time. And then it gives me at least Tuesday, Wednesday, Thursday to fix it, right? Before they actually notice that their Friday application might also be affected.
Yeah, and if you can split the Monday class into 4 groups, spread across the 4 instances, if one of those instances does experience a problem, at least the other 3/4 of the class can still continue.
Yeah, it buys me time to fix it. And like many sysadmins or that are probably listening, you know this thing, right? You fix a lot of things before it reaches actually the customer, before users actually see them. And they think, oh, it's just regular application running and everything is smooth sailing. But in the background, you did a lot of things to make that work or to fix the problems before they actually, occurred. Like the last bullet point here, monitor the disk space use and send alerts before the disk fills up. Many of these have like alert me at 5% or 10% or 20% disk full. And then you have time to react and buy a new disk or allocate more storage before it fills up to 0.
Yes, although for some of those, you do need to watch when using ZFS. Because of the way ZFS works, where your storage is pooled across many different file systems, the way like DF and some monitoring systems will report that is that each of your file systems is this, has this much data in it and has this much free space. And so the total size of that is X. And that X will keep going down as writes happen to other data sets, but the amount of data used in it isn't necessarily going up. So a data set can look like it's only 10% full, but in reality, the amount of free space is going down, and it's the alerting might not trigger as soon as you would like. Whereas if you alert instead on the amount of remaining free space rather than percent full, then you will get the alerts much sooner. And it's just kind of because DF and the tools that use the metric of percent full were designed before this concept where, the free space could be shared by multiple file systems. By, I'm writing to this file system. Why is it taking space away from that file system? But in pooled storage, that's just how it works.
Yeah. Or the monitoring tools need to have a ZFS aware disk space monitoring. So if you're a root on ZFS system, then that of course needs to be accounted for. And the DF, of course, as you
it can
said.
get really interesting when you have a reservation. If you're only monitoring your root file system and your root file system has a reservation to make sure it doesn't run out of space, make sure you're also monitoring the file system that is going to run out of space, like the one where you store the logs or the statement log.
Oh yeah, I have this the other day. I'm using Isinga to monitor. It doesn't matter what you use. It's just for alerting. When I run it on a different system, a Pudrea run, the monitoring on that goes crazy. Like, oh my God, where all these disk space full messages are coming from, because it creates these little jails to compile in and then destroys them again so fast that the alerting doesn't keep up. And I just turned it off for that server or for that particular compiling period. So yeah, monitoring is not the silver bullet here, but at least it can tell you a lot of things before they start becoming dumpster fire.
Yep. And then lastly, we have a comment from another attendee saying, apparently bash completions can stop working when you're out of space. And they ran into that recently.
Yeah.
Where it's like, so if you can't write the history file, that'll block it and it'll not be able to do your tab completions.
Yeah, I encourage everyone to try this out, like create a little jail or virtual machine and fill that up to the brim, and then try to do regular work in that and see what applications do or don't do, or how long it takes to do even simple tasks like ls or listing disk spaces. And you would, because you cannot look up stuff if you're not having an internet right next to you, because man, and looking up command switches, that takes a while to load and finding.
Yeah, it can especially be man pages, at least used to be gzipped, and then they would just ungzip when you open them. But if it wants to write that to a temporary file, that might not work.
Yeah. So in low memory, low disk space situations, you're very back to the roots. Okay, next story. CPU snowflakes in April. So the reason for that is, the backstory here is that the graphics group wanted to render some work, and that's a little bit later happening, and I'm now managing the big data cluster, which is basically a rack of machines for the CS department, where they do all kinds of big data management, not only management, but also teaching projects or thesis on those. So they need beefy machines to do all these calculations. So the graphics department one day comes along and asked, hey, can we do a little bit of rendering of our graphic stuff? You have a lot of CPUs in your cluster. Why don't we use them? Sure, I will be fine with that. And since we didn't have GPUs, we used to have GPUs in the cluster, but at the time it wasn't such a big thing, and they were quickly outdated. And once it became a thing to use GPUs for memory or for calculating intensive applications, they were all outdated by then. So they were fine using the CPU horsepower they had. And so they started logging in, and students got access, and they even wanted sudo access. And I'm, of course, reluctant to give it to them, but well, they promised to be nice and didn't do bad stuff. Okay, so I'm happy giving them the access. And the first thing is that they do is they install a GUI, because hey, it's a rack server. Why not run a GUI on that? Hey, I cannot work on the console. That's just outrageous these days, right? Okay, so why not use the console, or not use the desktop that they use at home or on their own systems, right? So before I know it, they install their own full-blown desktop. I know I don't want to, name names, whether it was GNOME or KDE or some other big desktop environment, but at least it was some big heavy application. And then one day I got an email saying, your cluster is slow. And I'm like, typically I don't get that very often, because usually it's much more than people even need. But here's the first picture. I looked up on the monitoring for that. Back in the day, I was using Moonin. And I have another couple of pictures the next couple of slides. But I have other means of monitoring these days. But it's good as a first start, and you get pretty pictures to see what's going on. So you can kind of see, this is from April 2016. I feel very old now. And so you can see that starting in the evening of the 24th, the CPU system time started climbing up and the idle time going low. So this is an 8 CPU system with 64 gigs of RAM. And that went on for quite a while. And you can see kind of, leveling out at like, what's this, 550% CPU power. So basically 5 cores are doing something very busy. So at the beginning, I thought, okay, they're doing their graphics calculations or their rendering or whatever they're doing. But they were reporting back that my cluster is slow, or this particular machine.
Well, especially
like, okay,
noticing that this is all system time and not user time means
right,
something interesting is going on there.
Yep. And this is the IO stat. I also grabbed this for historic revelations here, as we're doing right now. So it's also eating a little bit of IO each time, and there's a big spike there. I never recovered what that was coming from, but maybe that was some kind of bigger IO happening at one point, and it didn't kept on. So here I was looking at my disks, and of course CPU was the thing that they were using most, and they were complaining, hey, this is too slow, make it better, or give us a better machine. I was like, man, where this could be coming from, right? You start becoming a detective on your own system, never knowing what other people did and what kind of things are running. So, but looking at these graphs is giving you already quite of a good impression, like where's the problem coming from? Is it the disk? Is it memory? Is it some kind of other fault you haven't encountered yet? So it's also interesting, because many of these problems come because other users are trying things that you haven't tried. And students, of course, they are not malicious intended, at least not in this story. And they try out stuff, and you haven't on your own tried out this thing, and that way you don't know what the culprit is here.
Yeah, although
So
the first thing that jumps out to me here is that I see all 4 of your disks basically pegged at about 200 and some odd IOPS, which is about the max you can do in random IO off a hard drive. So it looks like your storage is just completely saturated until you see at the end there you made some change, and suddenly the storage isn't saturated anymore.
Yeah, this was when I found the thing. So that on the previous picture, you had this sudden drop, and that's where I found the problem, and that's why I recorded that, so that I would remember if I would have been given a talk like I do now. And so the solution to that was the next slide is
there was a question before that. They were just asking,
here we go.
Was this just one desktop environment being installed and all the users sharing that with VNC, or were they each, were you running multiple separate graphical environments?
No, that was just one, but you're right with the VNC. They couldn't be bothered going to the shell and doing SSH, right? They want to do VNC with graphics on their own machines. So they used VNC to connect to that desktop and then do their graphics work on them. Yeah, that's good. Yeah, so people can kind of get the idea where this is coming from. So the title of this was, just because you're a rendered snowflake does not mean people will see you. So it turns out if you have a desktop and you do the base install, then of course the GUIs also install screensavers by default. Nice little things for screens not burning in back in the day, but these days not such a big problem anymore. And of course the GUIs are running the screensavers by default if you don't configure anything else, which they didn't, to run when no one is working with the desktop remotely via VNC. And that particular screensaver was rendering snowflakes using 5 out of 8 CPUs to render those. That's not the intention of that system. They never wanted to render snowflakes, but the GPU or the screensaver was like, hey, I have a couple of CPUs, let's render snowflakes on a
I'm guessing
rack server.
in particular, that this screensaver wouldn't use very much horsepower on a machine that has a GPU. But a rack mount server that doesn't have a screen attached generally only has the very simple like BMC display, and so you're rendering all these graphics that are not complicated for a GPU, but on the CPU it takes a lot of horsepower to do all the vertex calculations to draw these snowflakes.
Yes, I'm fairly sure they were beautiful to look at in April. Well. So the rack server with no screen attached in the server room somewhere was busy doing snowflake rendering with no screen attached to see it. And the learnings here are, well, if students need help, then you should actually give it to them. But if they're kind of like, yeah, we know what we're doing, right? Just give us the access and the sudo permissions. I would, from that experience, just ask them, hey, what are you going to run, or what kind of software can I pre-install so that you can use it right away? They typically take this offer because less work for them. And like I said, they don't have any malicious intent, right? They just installed the desktop environment they know and used at their own systems. So they just went what they know and didn't had any intention that this was doing the screen saving thing on the rack server. But you kind of start thinking, hey, if this would happen again, how could I prevent that, right? How could I limit a certain application from running wild in this regard? And later on, I have a little bit about, resource limitation and, giving when you create a user, you will always ask, on FreeBSD at least, which logging group this user should belong to. And by default, the default logging group can use all the resources of the CPU or the system in general. But you could easily create your own login class and say, okay, only to a certain amount of memory, disk space, or CPU is that login group allowed to use the rest of the system resources.
Yeah, I remember back 20-ish years ago when renting out shells for IRC is that we would use login.conf to limit how many open file descriptors each user could have, so that certain users would be limited to only like 64 file descriptors, and if you needed more, you had to buy a more expensive account. Not really the case here, but by making sure that no one of the 200 students can use more than 5 or 10% of the machine, you make sure that no one person can bog it down for everyone.
Yeah, that's basically the Unix principle, right? A lot of people are using one machine and they need to share the resources. And with cloud computing, it's all coming back these days, right? It was the mainframe days.
Noisy neighbor problem and so on.
Yeah, it's just that they charge now for each CPU used. So yeah, let's go into the next bit, which is a bit more, teeth grinding, but also has a good amount of learnings in them. So finding Bitcoin miners eating your CPU. So you would think, oh my God, what kind of crazy environment is this? But again, these are the outliers and not the regular using students or the regular days that I have to content with. So not so typical day at work was the following. So that was also a couple of days later, or years even. So this is 2017 when this happened. So they were running in the masters a NoSQL database labs where they were given one machine in the rack for a team of 2, and they were getting a couple of NoSQL databases to learn and experience, like how they are used. There was MongoDB, and there was Hadoop, and there was Couchbase running on these systems. So, and the students got assignment, like figure out how the query interface works, or how fast they could load this amount of JSON or something, or do a couple of queries on that and see what the each individual databases report. Okay. So typically they work in pairs on each machine to, not get into each other's way. And there was, in this particular class, a latecomer that came, I think, a little bit later when the classes were assigned to students. And that happened that there was just this one student and couldn't find another partner because the other ones had already found a partner to work with. And there was only a single system left. So we assigned that single person to that single server. Okay, fine and good. And since students had no administrative rights given, no sudo, no act, no nothing, they could just run in their own home directory, and from there had these various NoSQL database interfaces available, plus some web interfaces that some of these NoSQL databases open, like Couchbase. That's basically a web application. And one morning, sipping my my beverage of choice, I'm looking at my machine metrics, and I'm coming up with this picture on the right. And that at first reminded me of my SETI at home days. Remember, where you can spend your idle CPU time to do some, finding the aliens out there, or for medical research. And I was kind of back in the day when that was still a thing, into this kind of thing. So that way, these CPU graphs looked familiar to me somehow. But looking at that, why is so much nice time used on a system that should be idle because the database lab is not running at that point? And out of curiosity, I log into that system, which I could. I'm the sysadmin, I should always be allowed. And what is this machine doing actually? Because the regular NoSQL databases don't have this kind of use case, or they use the regular CPU, not the
not nice.
The reserved base. And here I have a command called, this is the German top, but you can kind of get the columns are the same. The command there running next to Java and MongoD, the MongoDB daemon, is a CPU miner. And then my alerts got off, red alert, what's going on? I'm quickly running PS there, and I found that there is a certain application called CPU miner running with a couple of parameters. And one of the parameters that I, blanked out here to protect the, well, not the
guilty,
innocent, but the guilty, with a certain user account and a certain password that was, of course, blanked out, but I could find it. Doing some Europe Lyra 2 hub miningpoolhub.com. That sounds not too good, especially not for a database class. So I gather more information, what is this mining pool hub and what's a CPU miner? So it turns out this is a binary running out of the student's home directory. You don't need any permissions or sudo to run your own binaries in your home directory. You don't even need to run elevated permissions. You can run applications as a regular user. That's just fair and do. And that CPU miner got downloaded from this GitHub URL. It's been a while. That hasn't got updated recently, but I guess there are forks of that or other applications with similar use cases. And that process, from the previous picture, was running under the university-wide unique student ID. So it was clear who was running that, not me. And this could only be that student because that was assigned to only the single person. Okay. So did that student graduate as a millionaire eventually? Turns out no, because I reported that to the professor and even to Dean, because, hey, in this kind of situation, you want to make sure that it's not you gets the blame, because sysadmins are the typical ones that are, oh, you ran that. You just, didn't hide it very well. yeah, but why would I report myself to the dean and professor? No, they looked at that output from PS and top and found, of course, this can't be only the student because his ID is in the command, which they probably didn't found. So the student got expelled from that course. And I was angry. First of all, not catching that earlier because this was running a couple of days already. But also this was a matter of pride, right? You're the sysadmin responsible for the system, and a student got through your defenses or your, bastion that they could do this thing that's outrageous. How could you ever become a sysadmin again, right? But I mean, this happens, right? You could have the best secured systems, but no one else can work with them, right? The backstory of that, the students came back the following year, did the same course, and that was done by a different professor because they switch sometimes, and was, with flying colors telling the professor, oh, how cool Bitcoin is. That was way before, Bitcoin was a thing, or whether, profits were pretty big. So this is just nothing. And even the Lira coin, I have no idea how much this is, but it's just, not too much. So they did graduate eventually, and I'm not sure if they did their thesis on Bitcoin or whatever, but I definitely kept an eye on that particular student. So I wish them well. The learnings here are, don't just collect a whole lot of metrics, check them, because I did look at this graph in the morning out of boredom, or before you go into email, check your little graphs there. But it could have easily happened weeks after, and then of course a lot more CPU time could have been spent on that. And if a certain
that's why having alerting is important as well as collecting the metrics, right?
Yeah. So that after a while you know what kind of loads on your system are normal and which ones are a little bit, okay, there's a little bit of spike because a lot of people are working on that, but then it goes down to a regular, threshold. But if it's something out of the ordinary that's going on for a while, like over a weekend or so, then you might look at that, or either adjust your thresholds, not to get alerts anymore, but at least to figure out, hey, what's the new normal, or is this out of the ordinary? And when the incidents occur, carefully collect evidence, because you're the sysadmin, you're the first person to get the blame, whether that's warranted or not. And if you can't protect yourself with the evidence that you collected, then of course they say, well, you forged the evidence and you changed the log files to, push that to someone else. No, make sure that these are valid things that other people could verify, and that the blame doesn't go on you because you're the sysadmin, and that the proper people, if they did something bad, get the blame. And always have ways to quickly lock out a user or a whole machine from the network, because when that happens, you want to limit the amount of free CPU cycles. And these days it's much more expensive to run certain systems, and electricity prices going up. That's becoming a real issue these days. So make sure that you have a way to lock out users when the evidence is clear that they should not be allowed there.
Right. Well, that extends beyond just like if there's a malicious user, yeah, you want to be able to lock them out. But if an account gets compromised and it's being used by not the correct person, then again, being able to lock them out of the whole network, or block a compromised machine from the rest of your network, is something you really want to have as a tool that you can deploy very quickly to isolate the spread of a problem while you work on mitigating it and cleaning it up.
Yeah, I mean, you could have easily run like a web shop or something, or a DDoS against other systems, and then you're really having a problem. Then I have a little epilogue here called In a Bitcoin Darkly, after a Star Trek episode. Oh, not again. So here on my Twitter, I posted a picture of another incident that happened, and that miner was called Bitcoin Dark, BTCD. And that thing I also discovered by a separate student who was apparently doing his thesis on that machine. So they typically get those machines for 6 months, so they have time to do their thesis on and do all kinds of calculations. And I typically don't watch them too much because, well, they should know what they're doing, and they're kind of at the end of their semester or their studies. And but in this incident, BTCD, you're kind of curious at the beginning, like, never heard about this application. What's it doing? And you enter that in Google or on GitHub even, and then you kind of find, oh, Bitcoin Dark, what's that? And turns out that is also using CPUs to mine certain Bitcoins. And by that time I was already, oh my God, not again. But then I was looking at what kind of things I could do to limit these kind of activities. So we, of course, blocked on the firewall from the university those mining pool hub websites, because really no one is interested in doing connections with those from the university net. So RCTL is a thing on FreeBSD where you can limit the amount of resources a certain process gets or a certain user. And you can limit that by CPU, memory, and I think also disk space, if I'm not mistaken.
Disk I/O, yeah.
Disk I/O, yeah. And with CPU set, you can say, okay, this particular process should only use one CPU or CPU 1, 2, 3, and the rest are for other people to use, right? You can bind certain applications to a core or a number of CPUs. So various options are available on FreeBSD, and I guess they weren't invented to, limit other people doing malicious stuff, but you could also use it for this kind of thing. You definitely want to have ways to not give all the resources of a machine to a certain user. And again, I can only stress this from all these 3 examples. Monitoring is definitely required, even if you don't look at them, because you always want to know what happened last Sunday at 3 a.m. when you need that.
Yeah.
And if you don't have that,
you always want to have the historic information to go backwards.
I think there's another question in the chat.
Yep. So yeah, we just got our first question here saying, have either of you ever had a use case to configure mandatory access control, and can you share how well it went? Also, the handbook implies that Mac is only available on UFS partitions. Has OpenZFS considered supporting it? So it depends which part of Mac. So in my past, I've had a use case for Mac where I created a small Mac module. I think it was like 40 or 50 lines of code or so, which allowed, so normally when you use chown to change the owner of a file, you can't change the owner to another person who isn't you. So you can change the group on a file and so on, but I can't take a file in my home directory and make the owner of it Benedict. And the main reasoning behind that originally was because then that file would be charged against Benedict's disk quota, not mine. And, that's evil. But I had a use case where customers needed to upload a file via a web application, and the web application knew what that user's username was and needed to be able to make the file owned by that user so that user would be able to access it when they log in. So we wrote this little Mac module that changes how FreeBSD's permissions work for chown. And it allowed basically, if your user ID was this specific user ID and you were in a jail and the file you were chowning wasn't currently owned by root and a number of other restrictions, then it would allow you to chown it to somebody else. So Mac, the framework covers a bunch of different things. So the loadable modules where you can change the security policy stuff, that does apply to ZFS, most of the VFS stuff and so on. There are other parts, like there's a Mac framework for like a file system firewall where you can do more fine-grained stuff. I don't know for sure if that works with ZFS or not. I think it's mostly done at the VFS layer, which is above ZFS, and so should apply to ZFS as well, but I don't know. And then when you get to storing more stuff like in the file system, I don't have the answer to that off the top of my head. So there might be parts of Mac that don't apply to ZFS, but I do know that the main stuff where you can, change security policy stuff with the Mac framework, that does work with ZFS, as I've done that before.
Yeah, you could really go fine-grained, not just RWX, user group and others, but really say, okay, this kind of permission.
Well, so this one
very
was
detailed.
Not so much file permissions as whether you can make policies about whether you're allowed to rename a file or not, or if you're allowed to chown a file or not, or if you're allowed to run chroot and a bunch of other things that are more technically more capabilities. So there's these permission checks in all over FreeBSD that are based on a capability, and you can use Mac to modify what the decision process for those capabilities. And that does work with ZFS. But there might be some other parts that don't.
Yep.
But we've built a number of interesting things with Mac at Clara. We've even built one to, because certain applications like Node.js always try to use the same port number. When you have multiple tenants on a machine, that doesn't work well. So we wrote a Mac module that actually will reassign the listening port numbers for things like Node.js to a different IP address, so that each customer can use port 5000 and not need to know that there are other customers that are also trying to use port 5000. So if you need help with Mac, definitely reach out to Clara. The next question.
Oh, and Gordon
was asking about the Postgres statement log. Is that a plain ASCII log file, or is it some binary log for replication?
Yeah, this is a plain ASCII. You can look at that and with less or cut even, and then find the actual statements that happened at a certain point or by a certain user. So this is plain text. So I think you're looking at compression ratios here on ZFS, and of course those compress very well with that standard, of course. And I have the logs on a separate data set below the Postgres database cluster, and the compression ratios are just amazing to see.
Right, because you'll want to use a large record size for the logs, whereas a smaller record size for the data.
Yeah.
It is interesting that those are ASCII then, because I know like in MySQL/MariaDB, those statement type logs are binary because they need to be able to parse them back for replaying them on the like a secondary lane, a replication setup, and so on. And so you have to use a tool to turn it back into plain text.
Yeah, the write ahead log is probably also in binary on Postgres.
Yes, that one.
But the regular statement log that you have
this is
configured
more,
as a logging.
The query log.
Yeah. And another
one. We have another question asking about trying to move all their different services into separate jails, but they have an example where they have a jailed process that needs to sniff network traffic. Have you ever jailed services like Zeek or Snort? I've not done that, but I have done a WireGuard VPN inside a jail, and it also needed to be able to use BPF and open the interface. And I needed to be able to use TCP dump inside the WireGuard jail in order to see the traffic. So I used a VNet jail, and so that involved giving the entire physical interface to the jail. And once that was there, it was just a matter of using the devfs rules to unhide the dev BPF and other bits that it might need access to, and then it was able to run those applications inside the VNet jail.
I like the question also from the other angle, like you have a couple of services already. How do I, after the fact, put them in their own jail, right? Now that they're already running. Do you set up another service and shut out the old one, or try to create the jail and then move everything into it?
Yeah, you usually want to treat the jail as a separate system. To be able to have access to the physical interface, it'll need to be a VNet jail instead of a regular jail. And most likely that will mean giving that entire interface to the jail, which might not be entirely what you're trying to do. Although you can probably do something like a bridge and an e-pair to siphon off all the traffic and send a copy, basically to like a prism, send a tap, send all the traffic into the jail for inspection, but then it wouldn't necessarily be able to control if the traffic passes through, which depending on, if it's something more like a deep traffic inspection for blocking stuff, then your configuration will have to be slightly different. But yes, you can do that in a jail if you use VNet, and you just have to use special devfs rules to unhide some of the devices from /dev that will need, like dev BPF.
Yeah, these are typical questions.
I don't know off the top of my head what is required to do netmap from within a jail. But I don't know that wouldn't work.
Yeah, but they're separate network stacks.
Yep. We might have time for one more quick question. Does anybody else have a question? Okay then.
But
thanks
yeah,
everyone for
thank you
coming,
again
and
for having
yes,
me.
thank you for sharing your stories with us, Benedict.
Yeah, if I have more, then we do another one of those.
Yeah.
They're certainly educational, and also, they have a little bit of, a fun part in them.
Yep.
All right. Thank
So
you
yes,
again, Clara and participants.
Yeah, and if you need help with a FreeBSD problem, or if you're having to get your traffic management software running inside of a jail, or need help with getting the Mac module to do what you need it to do, then, or otherwise need any support with FreeBSD, please reach out to us at clarasystems.com, and we look forward to seeing you again soon. Thank you.
Thank you too.